Hey, pre-calc students, Mr. Mitchell here. We're going to take a look at trig identities, improving, verifying them again today. I worked at that a little bit before. We're just going to get a little bit more into it. So you will want to get your notes out in Schoology 5.2. So take a look. We have secant squared, a theta minus 1 over secant squared, and that equals sine squared. So we're going to work with the left side here. When you're working with identities, you can work with either side, but you usually want to pick the more difficult looking side. So I see a secant squared. When I see the squared identities, it makes me think of the Pythagorean identities. So I'm looking at this one right here. I have a secant squared, and that equals 1 plus the tangent squared. So that's kind of where I'm at, or where my thought process is. Okay, so secant squared is 1 plus the tangent squared of theta, and then you still have a minus 1, and you still have a secant squared on the bottom. So when you simplify on the top, you just get tangent squared, because the positive 1 and the negative 1 cancel. So I need to get it into sine, and right now we're in tangent and secant. So I really want to get rid of that. So what I want to do is split it up into tangent over 1 times 1 over secant, both being squared, of course. And that still equals the sine squared. So tangent squared is really sine over cosine, sine squared over cosine squared. And then 1 over secant is really cosine squared. And that still equals sine squared on the right side. So what's going to happen is your cosines are going to cancel. And you're left with what you wanted all along. Okay, so you can kind of see the process of what you need to do using identities, using algebra to go through that problem. All right, so let's take a look at this. So I have 2 fractions, and the other side is equal to one thing. So again, I usually pick the more difficult side. So I'm going to work with the left side here, and I need to get 2 fractions into 1. And I'm going to do that by getting an LCD. So it's 1 minus the sine of alpha, 1 plus the sine of alpha as my LCD. And we still equal 2 secant squared of alpha. So whatever I do to the bottom, I have to do the top as well. So for this fraction, I multiply by 1 plus sine, so I have to multiply the top by 1 plus sine of alpha. And over here, I have to multiply by 1 minus the sine of alpha. So if you multiply through, you get 1 plus the sine of alpha on the top here. You get 1 minus the sine of alpha on the top here. You're still equal to 2 secant squared of alpha. Okay. And I do think I want to multiply the bottom out. If you're not sure, don't multiply it out until you're sure that you're going to want to do that. So if you multiply the bottom out, you do get 1 minus sine squared of alpha. They are a difference of squares. So the inner and outer terms when you FOIL do cancel. So you're going to put the 2 fractions together. And what happens on the top? You just get 2, because sine and negative sine cancel. So there's your bottom. Don't forget it still equals the right side. We didn't lose that yet. So I think that bottom is another identity as well. So I look at my identities. I got a sine squared. 1 minus sine squared is cosine squared. So from this identity, 1 minus sine squared is cosine squared. So the bottom here is cosine squared of alpha. And then a cosine squared on the bottom becomes a secant on the top, and secant squared in this case. And that's what I was supposed to get. All right. Okay, let's take a look at letter C here. So verify this identity. So I'm looking at the left side because it looks more complicated to equal the right. I don't think I want to FOIL because the right side is just one thing. And if I FOIL, I feel like I'm going to have at least 2 terms, if not 3 or 4 terms. So I think about making one of these into an identity. So tangent squared plus 1, I know is an identity. Here you go. Tangent squared plus 1 is secant squared. So I'm going to have secant squared of x. So what's cosine squared of x minus 1? Again, I'm not touching the right side. Got to leave that alone. So I go to my formula sheet. I need to use this identity, but I need to move some things around. So if you move the 1 over here on the left, so we need cosine squared minus 1, and you take the sine squared over to the right, that becomes a negative sine squared. So again, using this identity, moving things around, this equals negative sine squared of x. Well, we need to get it into tangent. So I have a secant. What if I make this 1 over cosine squared times negative sine squared over x, and that still equals negative tangent. So if you put these two as one fraction, you get negative sine squared over cosine squared. And then this is negative tangent from the quotient identity. Okay, so there's our proof. All right, let's take a look at letter D. So I have a tangent of x plus the cotangent of x equals secant x times cosecant x. So with this question, if I want to work on the right side, that's fine. If I want to work on the left side, that's fine. But I look at the left side, I got 2 things. I need to turn it into one. Like when I say one thing, there's no addition or subtraction. So I need to get these two, probably adding some kind of a fraction. So I see secant and cosecant. It's tangent and cotangent. So my thought process is if I can change tangent and a cotangent into sine and cosine, work with that a little bit, and then eventually change sine and cosine to secant and cosecant, I think that's my right train of thought. So tangent from my quotient identities is sine x over cosine x. And cotangent is cosine x over sine x. And we're still going to equal our right side. So again, those identities to show you, the quotient identities are right here. I'm using both of those in this problem. So we want to get the bottoms to be the same. So I need a cosine x, sine x on both bottoms, because that's going to be my LCD. We haven't touched the right side yet, so I will just copy that down. So what did I do from bottom to bottom here? I multiplied the top by sine. I multiplied the bottom by sine x. You have to multiply the top by sine x. So then what did you do from bottom to bottom here? You multiplied by the cosine. So you got to multiply the top by cosine. So when you do that on top, you get sine squared of x over cosine sine x. Then over here, you get cosine squared over cosine sine. And we still equal secant times the cosecant. So then we can put our 2 fractions together as cosine sine on the bottom. So then we'll have sine squared x plus cosine squared x on the top. And we still equal the secant times the cosecant. Okay, still equaling that on the right side. So on the top, that's Pythagorean identity. That one should start to become very familiar. Sine squared plus cosine squared is 1. So now what are we trying to get? This is the last step. Cosine on the bottom becomes a secant on the top. A sine on the bottom becomes a cosecant on the top. And that is exactly what I was supposed to get. Okay. All right, so letter E. We have a secant plus a tangent equals a cosine over 1 minus sine. Now, up until this point, we've always worked with the left side. You can choose to work with either side. In this problem, I'm going to choose to work with the right side. I want to show you a different, maybe a little different method to approach some of these. So we're going to focus on what I would call this is rationalizing the denominator. Could also call it multiplying by the conjugate. We've done that before with square roots and with imaginaries. So this particular problem, we are going to not touch the left side. We could have done this before. It doesn't matter which side you work with. You just have to be consistent. So what I'm going to do, I'm going to not multiply the top out until I know I need to. I am going to multiply the bottom out because I'm going to get 1 minus sine squared. Again, when you're multiplying conjugate pairs, the inner and outer terms cancel. Okay. So recopying the left, not going to touch the top yet. Let me move me out of the way, huh? So that's 1 plus sine of y. Now look at the bottom. What's 1 minus sine squared? Well, Pythagorean identity, that's cosine. All right, you need to have your formula sheet in front of you while you're completing these. So that's this identity again. Okay, you can move things around in the identity to use them. Well, at this point, there was a reason I didn't want to multiply the top out. It's because I knew that a cosine was going to cancel. All right, the cosine, the one cosine on the top is going to cancel with one of them on the bottom. So the one cosine on the top canceled with one of them on the bottom. Again, we are still equal to what's on the left side. So now what we want to do is, we have two things here. We have really one thing. We want to split that up into two things. So split the denominator, split the top into two different things with the same denominator. And I think we're one step away and then we're done. What's 1 over cosine? That's secant, that's an identity. And then sine over cosine is the tangent. And that is what I wanted. Let's take a look at letter F. So we could work with the right side here again. We would have to rationalize the top, or we would have to split it up into two fractions and kind of work it with that. I think working with the left side is going to be our best bet. So I see a cotangent squared, and that reminds me of an identity here. So if you move the 1 over there, then that's cotangent squared. So the top is cosecant squared. Oops, not sure what happened there. The top is cosecant squared minus 1 over 1 plus cosecant. And we're still equaling the right side. Okay. So what if I factor the top here? So I'd have cosecant of theta plus 1 times cosecant of theta minus 1. And then on the bottom, I got 1 plus cosecant of theta. Didn't touch the right side. So now if you look, these two things are going to cancel. So I'm going to have the cosecant of theta minus 1 equals 1 minus the sine of theta over the sine of theta. And so you might say, well, how am I going to get this? Well, I have to convert this to sine. So this is going to be 1 over sine minus 1. And it still equals my right side. I haven't touched it. So here, I really only have one fraction on the right side. Here I have 2. So we're going to have to make this into one fraction. And again, I still equal the right side the whole time. I'm not touching that. So what's my LCD? What's my common denominator? It's got to be sine. This is 1 over 1. So what did I do from bottom to bottom here? I did nothing, so do nothing to the top. What did I do from bottom to bottom here? I multiplied by sign, so multiply the top by sign. I think we're one step away. When you put two fractions together, the bottom stays the same. The top is just 1 minus the sine of theta, and that's what I'm supposed to equal. All right, let's take a look at letter G. Only a couple more. So verify that the tangent to the fourth of x equals the tangent squared times the secant squared minus the tangent squared. So I'm thinking we want to work with the right side here. So our answer is going to be tangent to the fourth. When I look at this, I see a tangent squared and a tangent squared. Why don't I try to factor that out? What do I have left? I'm going to have a secant squared minus 1. Remember, when you factor something out, it doesn't become a 0 if nothing's there. There's a 1. If you distribute back through, you get what you started with. So I have kind of half of what I'm looking for. I have tangent squared. I need tangent to the fourth. Well, what's secant squared minus 1? That looks like an identity. Secant squared minus 1, if you look at this identity and you bring the 1 over, that's tangent squared. That's really what I need it to be. So this thing in parentheses is really tangent squared. Well, what's tangent squared times tangent squared? Tangent to the fourth, which is what I wanted. Okay. Only a couple more and we're done. So I have sine cubed times the cosine of the fourth equals cosine of the fourth minus the cosine to the sixth, and that's all times sine. So somehow, here's a sine. Here's a sine cubed. This mess has got to make up a lot of stuff if I'm going to work with the right side, and I think I'm going to. So I'm going to leave this as sine cubed of x, cosine squared, cosine to the fourth. When I look at this, I need a cosine to the fourth. Couldn't I, between these two, factor out a cosine to the fourth? So what if I factor out cosine to the fourth? What am I left with inside? Well, that would be a 1 minus cosine squared. And then I still have my sine here at the end. So if I look at what I got a cosine to the fourth on both sides. I need that. I have a sine. I need a sine cubed. So I need 2 more. I need sine squared really somewhere. Well, look at what we have in parentheses. 1 minus cosine squared. That's sine squared. That's the Pythagorean identity just moved around. So we are one step away and then we're done. Cosine to the fourth. Sine squared times sine. Sine cubed. All right, I'm just gonna give myself a little more space to work with this one. So we have cosecant to the fourth times cotangent on the left side. And then on the right side, we have cosecant squared times the cotangent plus cotangent cubed. So with the parentheses, I'm thinking that's the side I want to work with. So I'm going to leave the left side alone. If you notice, I have a cosecant squared already. I need cosecant to the fourth. So somehow I need to come up with 2 more cosecants, if that makes sense. So I'm going to leave that piece alone for right now. What I have here, what if I need to get a single cotangent? What if I factor out a cotangent? I'm going to write it over here so it's kind of out of the way a little bit. But if I factored out a cotangent out of both of these and put it out here, I would get 1 plus the cotangent squared. All right. So leaving the left side alone and leaving this alone. What's 1 plus the cotangent squared? Well, that's an identity. So let's go look at it. 1 plus the cotangent squared is cosecant squared. So that's right there. This parenthesis, Sorry about that. This is the cosecant squared of x. And I think we're one step away and we're done. That's the cosecant to the fourth times the cotangent. And that's it. All right. So hopefully this makes sense and is able to help you with verifying trig identities. Let me know if you have any questions.